Hi everyone, my name is Amber. I work at TNO, specifically TNO Vector, the Center for Societal Innovation and Strategy. And what we do is quite often in advice on strategy and policy making to governments and policymakers. I work there as a senior scientist. I'm also looking for my clicker. A senior scientist on innovation policy, specializing on emerging technologies and ecosystems as well. Today I'm going to present to you building the society quantum connection, because I am here representing more as a social scientist rather than a quantum specialist in deep sense, and then I mean the technical sense. And I have brought you three main messages. My first is, so I'm going to cover all three of them. I argue, 1, quantum innovation needs more than RD&I. 2, acceleration of quantum innovations, time to market. By considering the quantum connection. There is a mistake there, but the acceleration of quantum innovations and the time to market can be accelerated if you consider the society quantum connection. And 3, remain realistic. Don't expect everyone to be the early innovators. So I'm covering all three of them. First, quantum needs more than RD&I. So when I've been going about in the conferences this week here in Korea on quantum technology, I see a predominant focus on the RD&I part. So a lot of technical talks about what is needed to advance this field, and all of that is very important and very necessary. But it's also considered societal aspects are part of the development of this technology. And quite often they are considered, but certain aspects of what is societal research. So you see a lot of focus on education and the future workforce, the diversity in the field, sustainability sometimes, outreach and communication. But the field of social science is way bigger than that. And also there are lots of insights that you can gain if you look at an emerging technology like quantum from a social scientific perspective. And therefore I would argue there's much space for societal research on quantum innovations, and a concerted effort is needed. You need to do it together. And I would argue they would provide more meaningful applications of quantum technologies for use cases, for example, for which there is actual demand or desire. And that brings me to my second point. Maybe there's also value in considering a more demand-driven design of quantum technologies. So despite the potential of quantum technologies, its emergent status and its complexity make it hard for any deploying domain to understand its value or its prospective value in the future. So what can this application mean for certain societal domains with real societal problems at this point in time? And that's why we quite often see that these kind of technologies remain in their so-called STI silo. So they live in STI development, they live in their labs quite often, and the transition from the lab to the market is quite long and difficult to be made. However, when you build the quantum society connection by showcasing possible alignment between this RD&I development and the domain-driven demands, you can actually build the connection between the STI technological developments and the domains that actually want and need those solutions. And here on this picture I show you one exercise that we did when we focused on the applications of quantum technologies in the energy sector. And you can also see that in this picture we showcased quantum technologies in different colors. You have different applications that are possible, and we did so from the basis of this exploration is the main bottlenecks that are currently present in the energy transition domain. So not necessarily quantum bottlenecks, but energy transition domain have their own challenges, their own innovations that they need and require, and current solutions don't necessarily have all the answers. So by bridging this connection, you can actually start to build a bridge between this world of quantum and this world of the energy transition, because in social life, these are quite different domains that live next to each other, basically. So perhaps then demand is the trigger for accelerating the quantum innovation and accelerating the time needed to transition from lab to market. And then finally, I argue you need to remain realistic. And what I mean with this is, when you do an exercise like this and you go to energy domain organizations, quite often many of the people you meet are not necessarily the innovators. So I use this technology adoption curve as an example, that perhaps most of the people within the quantum domain are considered the innovators, and they are really early adopters of a new technology. But when you go to an organization, what you meet are also people that are in the late majority. They need significant convincing before they might ever consider this as an option. Or you might even speak to the laggards, the critics, and the skeptics that might be the very last person that will ever be convinced that quantum is a solution. So when you go about in society and you start talking about quantum technologies, realize that not everyone is an early adopter of the technology, but you can find within the organizations that you're going to speak to the early adopters that are interested in this technology and that are willing to work together with you on finding those solutions and finding those possibilities together. So find the advocates. And that's my presentation. Thank you.